A, negative 2, 3, B, 2, negative 1, C, 5, 0, and D, x, y are vertices of the parallelogram ABCD. A, find vector AB and vector DC, hence find the coordinate of D. B, calculate correct to one decimal place the magnitude of vector DB. So these are the vectors, or these are the points that we have, and they are points of a parallelogram. Now a parallelogram is a four-sided figure, and it has got its opposite sides parallel and equal. So there is the shape of a parallelogram, and we have A, B, C, and D. So the lines A, B, that is A to B, and DC are parallel. So you can see that I've illustrated with the two arrows to show that these two lines are parallel, and I am also illustrating this with only one arrow to show that these two lines are also parallel. And of course, let me put two bars on these to show that the two lines are of equal length, and these two just one to show that these two lines are also of equal length. So that is the parallelogram that we have here, and let me put the points here. So we have negative 2, 3, and B is 2, negative 1, C is 5, 0, and D is x, y. So we don't know the points, the coordinates of the point D. And 1, for a parallelogram, let me say this thing here. The opposite sides are equal. In other words, the vector that is from A to D, vector AD, that is from A to D is equal to from B to C. And vector deals with direction, so you have to observe the direction very well. That is, when you move from A to D, it should be the same as from B to C, but from A to D is not the same as from C to B. So we can also say that when you move from A to B, that is from this point to that point, it should be the same as from D to C. Yeah, and we can equally say that if you move from C to B, that is down here, C to B, this should be the same as from D to A. So when you move from up down, you should also move from up down over there. So they have the same directions, they have the same magnitudes, and these two opposite sides are equal. Now the question 1A says that we have to find the vector AB. So that is what we're going to do here. And if you are asked to find a vector and you know the individual points that make up the vector, that should be pretty simple. Now vector AB means the vector from A to B. We have 2 points, so vector AB comprises 2 points. And when we can split this vector into 8 constituent points, these are the A and B, and when you want to do that, you take the point behind, that is the point B, then you subtract the first point from it. That is what we call position vectors. And in vectors, when you use capital letters, we don't just write one capital letter, we use 2 capital letters. So each of these points is with respect to the origin. So instead of saying B minus A, we say the vector OB minus the vector OA. So that is to tell you that if I say vector OB, that means the point B, and vector OA, I mean the point A. Alright, finding the vector AB, I know the vector OB. The vector OB is the same as the point B. The point B is 2, negative 1. So under the vector OB, I write 2, negative 1, minus, then under the vector OA, I write the point negative 2, 3. Alright, so that is what I have here. So if you look at what we have here, we have 2 minus negative 2. So it's something like this. Let me write it over there. We subtract the corresponding coordinate. For the x-axis, we have 2 minus negative 2. That is what we see here. And for the y-axis too, we have negative 1 here, negative 1 minus again 3. So that is what we have here. And when these two negative signs meet, it tends to be positive. So 2 minus negative 2 is 2 plus 2, and that is 4. But 1 minus negative 3 is negative 4. So be very careful here. If you have something like this, minus 2 or negative 2 minus 2, that is different from this. You see, Let me call this I and this I. Negative 2 minus 2. This negative sign affects the 2. So the 2 is negative. And this negative sign also affects the 2. The 2 here, 2 is negative. And the two signs are not meeting. So here you have negative 2. Here you have negative 2. So if you have 2, negative 2, so that means you have 4. Sorry, negative 4. Because here we have negative 2 and here we have negative 2. Now, if you look at this, here we have negative 2, all right, but this negative sign does not affect this 2. This 2 is positive. So this negative sign is again affecting this negative 2. So when a negative sign affects another negative, it negates it, it turns the whole thing to positive. So here will be 2 plus 2. So negative 2 minus 2 is minus 4, but 2 minus negative 2 is positive 4. And that is why here negative 1 minus 3, we have negative 1 and we have a negative 3. So that turns to a negative 4. But with 2 minus negative 2, we have 4. So here will be negative 4. So the vector AB is 4, negative 4. As simple as that. All right, we get to the vector DC here. So let us find the vector DC. Vector DC comprises the 2 points D and C, and we call these position vectors, as I've said earlier on. So you split this into its constituent point, that is D and C, but you know the point that comes, that is the second point, comes first. So the point behind comes first. So the point C, and we don't just say C, we say OC. So minus the point D, and we don't just say D, we say OD. So the point OC, or the vector OC, that is the point C, is 5, 0. Looking at the question, we have 5, 0. That is the point C is 5, 0. So C is 5 on 0 minus the point D. From the question to the point D is XY. So we have XY. So we write XY here. So the vector DC is this. So let me simplify this. So 5 minus x, we are going to have 5 minus x here. Then here we will have 0 minus y. So we have 0 minus y, something like that. If I simplify this further, I'm going to get 5 minus x, but 0 minus y is negative y. But to find, the coordinates of the vector DC, I must know x and y. And that is where we go to the idea or the characteristics of the four-figure or the plane figure parallelogram. We have said that the opposite sides are equal. So that means that here we want to find DC, but we know AB. So this means that from D to C, DC is the same as AB because the opposite sides are parallel and equal. But do we know AB? Of course, yes, we know AB. So we say, but the vector DC is equal to the vector AB. So DC is 5 minus x on negative y, and then the vector AB, we just found the vector AB somewhere here. Let me look at it. Yeah, it's here, 4 minus 4. So we have 4 minus 4 here. So that is called equality of vectors. These two vectors are the same. The one on the left and right are the same. So we equate their corresponding coordinates. So with the top one, we have 5 minus x equals 4, and then the down one we have negative y equals negative 4. So with this, we can find x here. Okay, let me add x to both sides, or let me send the negative x to the right side. So when it comes here, we have positive here, 5 is here. Let me bring this one here, we have negative 4. If I subtract 4 from that, I have 1, so x is 1 here. Okay, and here too, let me make y the subjects. I need to divide both sides by negative 1 to get rid of the negative sign here. So y will be equal to 4. So this means x is 1 and y is 4. And what does the question say? It says find the coordinates of these. So these are the coordinates of D. So the coordinates of D, therefore the coordinates of D are x is 1 and y is 4. So these are the coordinates of D. Now let's look at the B. It says that calculate correct to one decimal place the magnitude of the vector DB. So first, let me come over here. B, we have the vector dB. That is the vector dB, and we see something like this. So this means the magnitude of vector dB. So to find the magnitude of vector dB, we must first find the vector dB. So what is the vector dB? Vector dB comprises the points D and B. We can split this vector into 8 points. The point that is behind first, so B first, minus the D, and as I did say, or I continue to say, we don't say B, we say vector OB, and we say vector OD. Now what is B? B, or vector OB, is 2, -1. So we have 2, -1. And D, or vector OD, we found it right down here. That is 1, 4. So we know this as 1, 4. All right. So we have 2 minus 1, and that is 1. And we have -1 minus 4. That should be -5. So vector dB is 1, -5. But that is the vector. We've been asked to find not just the vector, but that is the vector, but the magnitude of the vector. So the magnitude will be the square root of the x part squared, that is 1 squared, and the y part squared, that is -5 squared. So we have the square root of 1 squared is 1, -5 squared is 25, and 1 plus 25 is 26. So there is 26 units, and this is the magnitude of the vector. So when you convert this to decimals, you get something like 5.1 units if you want. All right, so that's how we do it.